Hi, hello friends. Today we are going to see about double linked list. So first we have the standard input output library header file, and we also have the stl.h. This library is literally for MLOC keyword. So it's basically like allocates memory for our node here. Initially I am declaring the struct with the name node, and I also am declaring two pointers named previous and next. This will be using for addition and next of nodes, and then I have an integer variable called data. Basically this will be storing the data that will be giving as the input in the nodes. So I also have the pointer named red, which is all the strike mode. Next what I'm doing is I'm having like 5 functions. So the first function is insert beginning. This function is basically insert followed by insert last, which will be insert the node at the end of the double linked list, and then we will have the beginning, which basically deletes node from the beginning of the list, and delete last deletes the node from the last, and finally we have void display is displaying all the elements the data linked list. So first we start with the main function void main. Here we have the integer data type variable called choice. So this we have used this for choosing an option from the menu that we are displaying at the beginning. I am using a while condition for the choice, typing int for not equal to 6. First I have a printf statement called main menu. Say that I have print statement called choose an option from the following. Set in the beginning, second insert at the last, delete at the last. Basically we are deleting nodes in the data link list, and finally we have display, which is going to display all the elements of the linked list. Now I have a scanner statement for getting the choice of the user, whether that they have to insert or delete display the elements of the nodes, elements of the list, and then I have a switch case for the variable choice. For case 1 I have called the function insert beginning initially declared before the main function, and then for case 2 I have insert the last first delete beginning, for case 4 delete last, and the user gives any other input apart from this file. I will use the default segment, which will print me the please enter a valid choice. So now we are going to define all the 5 functions we mentioned previously: insert beginning, insert last, delete beginning, delete last, and display. So let's start with insert beginning. So this function is going to determine nothing, insert a void insert beginning followed by parenthesis, and inside that I have a pointer called p, and then I have an integer data type called item. Basically I have told earlier this item is going to store the data into the node of the double linked list. So what I am doing here is for the variable p actually allocating a dynamic memory allocation, which is of the state of the struct one we declared initially. Dynamic memory will be allocated of the size of the struct node, and that can be stored in the address of the p. First thing I am checking where the pointer is equals null. The p initially declares null. That is the case. I am printing in this as overflow. Here is the main part of the code. Else statement inside that I am and another if and else condition in the statement. Else I have print the printf statement. I have print statement enter item value. So this will be basically after that I will have the scanf statement. basically get the input from the user from which at that I have been insert at the beginning of the node. Insert beginning function, this will insert the value inside the node at the beginning. So the first condition I'm checking is if head equals null. So they can be basically two choice. The first case can be either linked list is empty. That's what we mean here by equals null. If the head is the pointer and points the first node of the in linked list, it equals null means that's the data, no nodes inside a double linked list in that case. So that node that we are inserting now will be the first node of the linked list. What I'm doing is I'm assigning the p of x next to be null. Basically there are no linked lists inside the linked list. P of next, p of previous will all automatically be null. What I'm doing next is I'm assigning p of data, the item value to b of data, what care using the scanf statement. After that, what I'm doing is since we inserted a node inside a double linked list, I'm changing the head value to the pointer p, so that will be first element of the double linked list. Else if I can enter a value at the beginning in an already existing double linked list. The double linked list that is an already having a node. So that case what I will be doing is I will be assigning the item and got using the scanf statement p of data. What I'll be doing is assigning null to the previous of the p pointer, and then to the next pointer we are assigning the null, the pointer that are given now to be the first node of the double linked list. The head of the p will be p. Finally p have been inserted node of the beginning. So the head pointer should be pointer b that have been created. After this I am giving print statement called a node is inserted, so that will be our first function in the beginning. So this is followed by insert at last. So here what we are going to do is insert a node as the last of the double linked list. For that, once again we are going initialize a pointer variable p, and we also having temporary variable here, and it will be why I am using that. So I got an item of the data type, item variable of the data type integer. Here once I am going to dynamically allocate the memory for with the size of the struct node, store that the address into p equals null. I will be printing overflow, else I will be going into the function of inserting node into the last of the double linked list. Once again I will be getting input from the user which I enter into the node. So for that I have the scanf statement and the printf statement. What I will be doing here is I will be storing the p of data into the item. After getting the input, here I am once again going to check head is equals to null. Once I am being basically checking data inside the node or not. So there is no data inside the node. What I'll be doing is I'm going to assign null for both the pointer of next and p of previous, and then I will be assigning previous. This is basically what I have done at the for the previous function where we have inserted a node in the beginning. So after that what we have is I'm going to have a temporary variable. I'm going to have the temporary variable store the value of x last of the node. So basically I have other node to double linked list. What I'm doing is I'm having a temporary variable, using that I'm using that temp variable to traverse to the last of the double linked list. I am going to have temp equals right. I'm using a while statement. Basically, what will the while loop does is it travels to the last of the double linked list. After traversing to the last, until that, what happens is temp will be traversed to the next. For temp is equal to temp of next until you find the last element. Next address will be null. So that's what we are having as a condition inside this while loop. And temp equals to temp of next is equal to until that we traversing to the last of the double linked list. After that, what we have is once it reaches that last node of a double linked list, it get out of the while condition, and what we'll do is it will assign temp of next point will be allocated next previously. P of previous will now assign P of previous will next assign to null. What we'll basically do is make our node to be inserted at the last of our double linked list. After that, what I have is a print statement indicating that node is inserted. Now we have the delete beginning and delete last. Let's have a look on the delete beginning and the delete last function. Finally, we have the look on the display function. Basically, the delete beginning function, we have a pointer of the type struct node, and then we check whether double linked list is empty. For that, we use the conditional statement ed equals null. That basically means there are no nodes inside the double linked list. That case, we cannot delete nodes from the double linked list that have no nodes. In that case, I print that underflowing. Then I have this else if statement. Inside that, head of next equals null. So this basically means that the node inside our double linked list is the only node. We can also say that is the first and last node. In that case, I directly assign the value of head to be null, free the memory allocated for head pointer. After that, I will be printing deleted. Other scenario is like n number of nodes inside the double linked list. Particularly delete the first node of our double linked list. In that case, what I am doing is I am assigning the value of it to the pointer p, and then what I am doing is moving the head pointer to the next node, and then head of the previous will become null. So that case, what will happen is our head pointer will move from the first to the next node. That means head will now be pointed in the second node of our double linked list. In that case, the head moves. There is no need of the allocating memory, especially for our pointer. So I am free getting rid of the memory allocated to the pointer p, free of p command, and then what I am printing is the node has been deleted. Delete beginning. Now let's move on to the delete last function. So here also I am initializing a variable called p of the type struct node. It's a pointer variable. Once I am checking double linked list is empty using head equals null. In that case, we cannot del any node from the double linked list. I am printing underflow. Next, what I am doing is once again checking it is like the only node present inside our double linked list. In that case, I will be assigning the value of head to be null, and then we getting rid of the memory allocated for the head, free of head. Print node. The node has been deleted. Just to the node has been deleted, and then what we have is the next scenario n number of nodes inside the double linked list. I have particularly delete the last of the double linked list. In that case, what I do is I will be assigning the value of 8 to the pointer temporarily for the pointer p, and I will be having a while condition. Inside that while condition, what I will be doing is basically traversing to the last of the double linked list. For that I will be p of next is not equal to null, p is equal to p of next. So this will keep on repeating until I must move to the last of the double linked list. After moving to the last element of the double linked list, I will do p of previous of next equals to null. What it will do is it will basically like the pointer will move to the previous element of from the last of the double linked list. After that, we will be getting rid of the space allocated for the pointer p. So it will be last node of the double linked list. Finally, I will be printing node printed. This is the last element of the double linked list. Void display function. It is just to have a clear understanding of the what happens as I perform the function. For that, it's a simple function. I have a pointer variable called p of the type struct node, and then I am printing the statement called printing values. As I am assigning a value p is equal to head, and then I have while condition where p is not equal to null. I print data until p is not equal to null. P is like the p will be having the value of address of it until keep on traversing like p of next we until we the last element of the double linked list. Until that time it will keep on traversing to the when it reaches last node of the double linked list, it will stop printing overall program. Now let's run the program. So it's asking set insert at last or to display the nodes into our double linked list. First set at the beginning of the double linked list. Let's see, data will be 25. I have got a command indicating that node has been indicated item inside the node, and as we could see, the first node has been printed. Set one node as the last of the double linked list. Set the last function, last of the double linked list. Beginning. Now you can see that output of the double linked list.